Start.
Hello everyone, this is Madhu Sirikonda and I'm dealing with strength of materials lab. In that we are going to discuss about the simply supported beam or the cantilever beam. So these are the two supports. We are having two different materials may be a different material. The first thing, the aim of this experiment is to determine the Young's modulus of given particular material by using this simply supported beam and cantilever beam. So the procedure goes like this. Let me describe you about this cantilever beam because it is fixed there. You have got two supports here. So the cantilever beam is you have got one fixed end, fixed support, and the other one is left free. It is a free end. At which, at this free end, we are going to give loads. There are different types of loads here. It measures 1 kg and a lighter one, half kg. So, after fixing this one, we have got one more provision to determine the deflection of this beam. The deflection of the beam can be determined by using this dial gauge. We call this as a dial gauge. It helps us to determine what is the deflection of the beam. So how to set up this dial gauge? To do one thing, you have got knob here, back side you have got knob. So you can release this one or you can tighten this one. You have got the provision here. So you can move this up, down and up. You can move like this, and you should adjust in such a way that the tip of this dial indicator is touching the beam. The tip must touch the beam. You should adjust like this. You can find a slight gap, a paper gap. Even that gap should not be there. Now, I slowly give the loads here. If I keep on increasing the load, say this is 1 kg. Now for 1 kg, what is the deflection in the beam is what you need to measure. So that I will show you. Yeah. Now you give the loads. See, you got deflection here, right? You got deflection. The count here it is if it completes this bigger pointer, if it completes one complete revolution, it means the deflection is 1 mm. Here you have got a counter also, a small pointer that will show you the counter. That will count how many circles or the revolutions that this bigger counter has completed. Remember one thing, if this bigger counter, this pointer is completed one revolution means 1 mm deflection has taken place. Now, so for 1 kg of load, here I got a deflection of 10, 20, 25, 26, 27 means 0.27 mm of deflection is occurred at the end or at the free end of this cantilever beam for 1 kg of the load for this particular material and for the given length. You can measure the length of the beam by using this tape, measuring tape. So this will come under the calculation part. So whatever in the tabular form, whatever the data is required, that you need to take. Here we require this length and width and thickness of the beam. You can use this vernier calipers. Its least count here, it is for this machine here, it is instrument, it is 0.02 is the least count on the vernier scale. You can use this vernier scale to find out its width and thickness by using vernier calipers. Now you slowly increase the loads. So for you repeat the same thing for different number of loads, and after doing calculations for Young's modulus for different things, you can take average. There should not be much difference between one load to the other load while calculating the Young's modulus. Even if we get it, I will explain you what to do in the calculations. Now the same thing can be done by using the simply supported beam. We need to change the supports. Same thing can be done by using this.